Absolute value inequalities. Let's take a quick look at an absolute value equation. So this one says the absolute value of x is equal to 5. So what does this actually mean? Since this 5 right here represents the distance from 0, we have to think about what numbers have a distance of 5 from 0. That's why this equation has two solutions. X could either be 5 or x could either be -5, because both of these numbers have a distance of 5 from the number 0. So that is your main clue to how this works. When you're doing the absolute values, remember, because absolute value measures the distance from 0, you can think of going in a negative direction, or you can think about going in a positive direction. That's why earlier we had two solutions. Either that could be 5 or -5. So remember, it's two possibilities when we talk about absolute value equations and inequalities. You got to think about going in a positive direction and a negative direction. All right, so I'm looking at an absolute value inequality right now. We're going to treat this like we do any other type of equation. First thing is this whole absolute value, I really want that to be by itself. So this -8, I'm going to go over here with it. So by adding 8 to both sides of the inequality, that's how I can at least get that part out the way, right? Now, because these signs are different, that's really subtraction, and what I'm getting is a -13. So that takes care of that part of the problem. Now it's over here. Now what I do bring down is this absolute value. Now I can drop this whole absolute value down, but it has a negative sign sitting on the outside of it. And remember, that's understood to be a -1. So all I really need to do is divide by -1. So that's going to take care of that part. So now the -1 part of it out the way, that's gone. And remember, anytime you divide by negative numbers on an inequality, it's going to make this sign do one of those. I can explain why in some other video, but just remember that's what's going to happen. So now I have a +13, and now my absolute value is all by itself. All right, so my absolute value is all by itself. You have to do that part of it first. That's before we even get to the real solution. All right, so kind of like we talked about before, when you have an absolute value and you set it equal to something, there's two possibilities, right? Now, this is an inequality, but that is where it is still similar. So what that really means is we have to think about, okay, what happens if I have a 3 minus a 2x and it's less than or equal to 13? That's what happens when we think about it as it is. But remember, we have a whole nother negative to think about, right? So we have to think about, okay, what about the 3 minus 2x? What happens if I flip all that and think about the negative of it? Because when I apply the negative, this is what happens. Now, the way I'm doing it right now is not like the books like to show it. They like to combine everything as one, but I like to really kind of explain it as two separate things. We're still going to get the same answer. So this comes down as it is, but then you have to think about the whole other side of it when this is flipped. And then you just solve these separately. You could take away 3 on both sides, and that gives you a 10 there. And now you have a -2x that drops down, and you can divide by a -2. And remember, we just divided by a negative number. That's going to flip. And that's a -5. That crosses out, and there's an x. So we know part of it. We come over here and solve this one. Cool thing is, we still subtract 3 on both sides. But now, that's a total, because these signs are the same, of -16. The -2x comes down. -2x comes down, and I divide by -2. Remember, I divided by a negative number. I flip that sign around. Negative divided by negative is a positive. Those are gone, and boom. There's the other one. One side gives you this. The other side gives you this. Now this says x is greater than or equal to 5. So that means if I put a dot over, that means I have to put a closed dot on my -5. And since this says greater than -5, you have to go in that direction, because that's greater than. Now this one says x is less than or equal to 8. So 8 sits over here, but less than goes that way. And therefore what really happens is we're talking about all of my solutions should land from this dot to that dot. Anything outside of where I've shaded will be false. Those would not be solutions. But these where your solutions will lie. That's where your statements will always be true. Inequality symbols flip when you divide negatives on both sides. It also happens if you multiply negatives on both sides, all right? Absolute values measures distance from 0. That's why you have to think of two different solutions.